Okay, so we're going to take a look at an example here. We want to take the Laplace transform of this product. We have the step function that turns on at time pi over 2 times this function sine of t. Okay, so in our example, we're going to be using formula 1, that the Laplace transform of UA of t times f of t is going to be e to the negative as times the Laplace transform of f of t plus a. Okay. In our example, a is equal to pi over 2, and f of t is equal to sine of t. Okay, and so then this is going to be equal to e to the negative pi over 2 times s. Okay, so it's in the frequency domain times the Laplace transform, and we're going to make a shift in the time domain. So we have f of t plus pi over 2 is e to the negative pi over 2s times the Laplace transform of sine of t plus pi over 2. Okay. So we have to know what that function is. Let's take a look at a sketch of this. We're going to just start with the graph of sine of t. I'm going to sketch that up for you one moment. Okay, so we start with this graph of sine of t, and then we want to shift everything left by pi over 2. So when we see plus here, that means left. Okay, so all of our graph is going to just scoot to the left by pi over 2. Okay. And so the function whose graph we produce then, this is actually the cosine graph. Okay, so we see that at time 0, it's equal to 1. And so this guy is just cosine of t. So sine of t plus pi over 2 plus cosine. And so that means that we can write this as e to the negative pi over 2s times the Laplace transform of the cosine function, or e to the negative pi over 2s times s over s squared plus 1. Okay. If it was a function we didn't recognize, we would have to either go to the definition in order to go forward, or yeah, we might be out of luck. Okay. All right, let's give it another one a try. So here we've got these two pieces. We've got the Laplace transform of t, and then t squared multiplied by this step function that turns on at time 1. Okay. All right, so the first piece has no step functions, so we can just go ahead and take its Laplace transform. And then we'll take the Laplace transform of this step function that turns on at 1 times t squared. Okay, so our first term gives us 1 over s squared. And then the second one gives us e to the negative 1 times s, or e to the negative s, because a here is 1. And our f of t, the function it's multiplying, is equal to t squared. This is times the Laplace transform of f of t plus 1. So we're going to shift that function t squared to the left by 1. And so that's 1 over s squared minus e to the negative s times the Laplace transform of, we're going to be changing the inside of our squaring function. So this will be t plus 1 squared. Okay. And to easily compute this, we can just distribute, just like if you had much like before we learned, like you said, we would distribute our products and powers before we integrated. Okay. All right, so this is going to be 1 over s squared minus e to the negative s times the Laplace transform of t squared plus 2t plus 1. Okay. And now each of these pieces, we can take the Laplace transform of, no problem. So t squared, if we take a look at our list here, if we have t squared, then the Laplace transform of this is going to be 2 factorial over s to the 2 plus 1, or 2 factorial over s cubed. Okay, let's go back. Okay, and so we have 2 over s cubed plus 2 over s squared plus 1 over s. Okay. All right. And a question that comes up frequently is whether or not we can combine these two pieces, the piece that with an e to the negative s factor and the piece without. And although algebraically we could write them as a single term, it will really rarely be helpful to combine them. Instead, we're going to keep things grouped based off of the exponential that is multiplying them. So keep things together based off of the exponentials, and don't worry about moving things around. Okay. All right, so this is our forward direction. Now we're going to work on the backwards direction. So going from an exponential term e to the negative 2s times some function in terms of s, how do we find the step function that it came from? So let's look at that next.